Good morning, everyone. Uh, I'm very happy to introduce Dry McNeil. He's a developer evangelist at Get Key, helping people figure out how to best use Get and Get-based tools to get their work done. Outside of the tech, Dry is improving in Chicago and also is a huge fan of the karaoke and the Kent and the clock chart. Feel free to ask him about any of those and over the Twitter where you can find him as a McDwayne, McDwayne. Hope this helps. And now I give the everything to speaker, and I will record the voice. Thank you.
Thank you very much for that introduction, David. Hey, everybody at B-Sides Tampa. Very, very honored and pleased to be here with y'all. So, as I was introduced, I'm Dwayne. Let me get my slides moving. There we go. So, I'm Dwayne. I live in Chicago, Illinois. So, I'm doing this remotely. I tried to come down that way, but just did not work out. And also, excuse me if you see me looking up and to the left. I'm on two monitors here and just making sure that I'm monitoring the chat as well. So if you do have questions, feel free to throw them in the chat here inside of the web app, and I will try to reply to them as quick as I can. Yeah, I was just introduced. I'm also a improviser here in Chicago, affiliated with the Annoyance and a few other theaters, as well as a huge fan of knit and crochet. I see a lot of overlap between yarn craft and what we do in computer science. Uh, Repeatedly doing loops and end up with beautiful projects. We can talk more about that later. If you have any questions about anything, feel free to hit me up on Twitter. That's the best way to get a hold of me, or feel free to email me at the end of this when I share my slides. I'll also share my email address with you. So I work for a company called GitKraken. We make legendary Git tools, a desktop client that makes it really easy to drag and drop things around and understand your histories and everything very simply. Uh, GitLens, which is the number one VS Code extension for Git, and Git integration for Jira, which is a tool that makes your life a little bit easier if you're using Jira to manage your projects. All right, enough about that. That's not why you came in here, but did want to give a shout out to the people that sponsored me to give talks. Um, so, why am I talking about Git at a security conference? This typically is a topic a lot of people associate with, well, that be for a specific code realm or a specific um, programming language, maybe a DevOps summit. And true, I've given this talk at a number of places, but I think it fits in with security folks extremely well because everybody uses Git. Uh, well, not everybody, but almost everyone you'll ever meet that pushes code uses Git. And where they push that code to go live somewhere on a server is somewhere like Azure or AWS or a Google Cloud product or their own server infrastructure. Wherever it is, it has a bunch of secrets associated with it, as well as the repository itself GitHub, GitLab, Bitbucket, wherever the code lives that eventually gets pushed to that DevOps service. It requires a lot of secrets, API keys, credentials, passwords, tokens, those long, really well thought out hashes that we use to plug in to verify we are who we say we are. Why I'm giving this talk is something I'm trying to raise awareness of out in the world is that people put things in their repos that they're not really supposed to. They put these secrets in places where people can easily get a hold of them. Uh, Git Guardian did a report back in 2020. I know it's 2022 right now, but they didn't put one out last year for some reason. But they found 2 million secrets on GitHub alone. Didn't even look at the other services out there. And what they found was it wasn't really malicious that people were, hey, I'm exposing this on purpose. It was, hey, I copied a secret to the wrong place and pushed it to a repo I wasn't supposed to. We're playing this constant game of cat and mouse with the world where we're trying to protect our data and people keep finding new ways to get at it. You can have the best security setup in the world. You can spend millions on rock solid infrastructure, really pen test everything, make sure everything is up to snuff. But if someone just leaves the key out front, if you walk up to a building and see, hey, there's a key under a rock here, it's pretty easy to get in. And again, I don't think anyone's doing this specifically maliciously. Well, some people probably are. There are bad actors out in the world. But I think it results from something like this. That is a really ridiculously complex door code. And I'm guessing whatever's behind that, the people in that building, the managers of this facility, thought, well, it's just pens. It's just staplers back here. Like people we're impending our flow. We are stopping people from getting their job done by implementing too good of security. And I know everyone cringes when you say too good of security. Yeah, this is a great door lock. It would take you forever to figure out how to get in here. But again, someone pasted the key out in front for everybody to see. And again, for this particular use case, maybe it wasn't that bad. Maybe there's nothing back there that is going to cause catastrophic failure for their company or cause a data breach. But okay, what does this have to do with code and Git? Well, you might not do this on your code repo and say, here is the secret, but this happens literally all the time. This is a little Go script I'm borrowing from someone. And when you look at the speaker notes, if you get your hands on these slides, it links back to the Medium article. I grabbed this, but I thought this was a good example. This is a bad idea. I think everyone that programs anything would agree this is a terrible idea. You should not be hard coding secrets. However, we all do it. Why do we do it? Because we need to make sure that database exists. We need to make sure the credentials are the right credentials. We need just a quick test that, hey, this does what it says it does. In a perfect world, we would put this in here, test it. Yes, it's up, and immediately delete it, and we would be safe. However, we know that these things keep getting leaked. And again, I don't think the problem is people say, hey, I'm going to put this in here and I'm going to leave it in there. I think what happens is people start checking, like, okay, this API endpoint is up, but wait a minute, I got this other problem down here in the code. And they start scrolling down. And now they're no longer on line 10, they're working on line 180. Meanwhile, the rest of the world keeps going on. They get a message from their partner on their phone. Someone on Slack said, hey, we got an emergency in production. Can you please jump over to this channel and work with us? And by the time we get back, we're human beings. We only have so much capacity for focus. We'll forget that we did this. I think that happens a lot, to the tune of millions of secrets get leaked a year. I have a friend who works for a company that just rotated 5,000 keys because they realized that in one error message, it spit back an SSH key because the way they configured it. It didn't just say the name of the SSH key, it spit back the whole key. They didn't know how long that had been going on, and it rotated 5,000 keys. That was one company. Those logs get into databases, those logs get into repos, they get exposed. Real quick, take a step back and say, well, okay, what does Git have to do with this still? Let's take a quick reminder of what Git's role is in all of this and how it's helping or hurting our security situation. So Git is a version control system invented by Linus Torvald with the Linux project 2005. Junio maintains it these days, Gitster. But basically, you take a snapshot of your work over time. This is awesome because you have access to all of those versions forever. You can stack those snapshots you take on top of each other, one on top of another, and you get these awesome graphs. And you can do very complex workflows with it. In fact, Git gives you a lot of awesome superpowers like time travel, where you can go back to any specific version you want. You can also branch off into multiple universes. Dealing with one universe and moving forward in time is really complicated. We're really good at it because we do it all the time unwillingly. That's just how reality works. Once you introduce concepts of parallel universe or branching and time travel with revert and checkouts uh, and switch, wow, that's a complicated universe to live in. And now there's a lot to keep track of. And then you tie it into the world of DevOps. Git sits in the middle of all of it. Without a transport layer to easily push around deltas, none of this works. GitOps is a thing for a reason. DevOps only works on the back of version control. We can argue it could exist with other versions of version control than Git. I'm not saying it couldn't. I'm saying Git won. Git is the de facto, and all of this, everything you're seeing on the screen, is built on the back of Git. Well, built to use Git anyway. So Git is awesome, but it itself is not a security tool. In fact, the people that invented it, the people that still write the manual for it, still to this day call it the stupid content tracker. If you type man git into a terminal, that's exactly what it tells you it is. So it's not a security tool into itself, but it does have a way to help with your security. If you know that there are things that you shouldn't ever commit, like your gem files or other things like secrets.json or a .aws file, you can make a git ignore file and say, hey, git, ignore these things. And every repo should have at least one git ignore file that lists at least these kind of secret checks. Um, in a perfect world, we would never, ever actually put our keys into our code. But again, we don't live in a perfect world. If we all kept our keys in, secrets.json and then just get ignored them, that would be the end of the talk. I would never have to bring up the rest of this talk again. That would be a perfect situation. And again, in a perfect world, people wouldn't be hard coding their secrets in the first place. So if we really study this, and I've looked at this a lot and thought about this a lot, the secret really isn't, or the problem really isn't that people do those quick tests. You're never going to be able to stop that. That's how development works. You just need to know that API endpoint is up. Um, the secret, the problem is that you've committed that secret, that it didn't just stay temporarily on your local machine for like a few seconds. That you committed it and then you pushed it somewhere. Now you have problems. If you commit your secrets and then push it out in the world, you're going to have a bad time. There's just no other way to really say that. Once it's pushed, there are tools that can immediately detect what's going on. So like SonarLint, Deep Source, GitHub's advanced security. We've all got those security alerts of like, hey, something's gone wrong somewhere. But it's like that old song from The Offspring. By the time you hear the sirens, it's already too late. Something bad has already probably happened. Again, because we're constantly battling the dark forces of bad actors out there. Uh, they're looking for any way in. And with automation, they're constantly scanning the same way that white hats are scanning for, hey, been a breach. They're scanning for any way they can get in. You can remove your secrets from your history, from your branches once they're pushed. Not saying you can't, but it's painful. It's very painful. It's not just painful in the sense that, okay, now I got to do surgery on my Git repo. That's fairly trivial. That's a bunch of command line runs or just thinking about how your data is stored. But now you got to go rotate those keys. How many keys would need rotated if one secret got leaked in your org? The thought of that should be overwhelmingly painful. There's a lot you need to do when you're rotating keys. Anyway, so what we need is some kind of automaton, some kind of robot that just stops us from doing this. Now, if we do this over the wire, if we do this as a service, then we start introducing problems of, hey, we have man in the middle attack vulnerabilities, we have encryption problems over the wire. There's a lot of things that can go wrong once we start relying on third party services. Again, once we pushed our code and it's been detected, it's already too late. So we need something local. Well, we already have something local. It's already baked into the entire process. It's the underlying linchpin of DevOps. It's Git. Inside of your .git folder, if you've never looked in your Git folders, I encourage it. Like, you probably have one on your desktop right now. Go open up a repo and dig into your Git folder. A lot of cool stuff in there. Uh, it's not as nearly as scary as you think it is, but one of those folders is the hooks folder. Hooks let you build your own anything. The very simple way hooks work are something triggers in Git, Git causes a script to run. That's basically it. I like this uh, picture. Rube Goldberg. This is one off Wikipedia, but a very complicated device that does something very simple. There are 17 hooks available to you. Um, though the ones we're caring about, the ones for how we're going to stop ourselves from committing something, is we need to, well, look before we commit something. There are three hooks that fire off before we actually make that commit: pre-commit, prepare commit message, and commit message. There's all sorts of things you can do with this. And one of my goals here is to encourage everyone to start thinking about, well, how else could I incorporate other security tools? How else could I also incorporate other security checks through this process? Because every bit of code, again, almost every bit of code in the world that goes through a DevOps cycle goes through all of these at some point. So if you want to learn more about this, I highly recommend githooks.com. Matt Houston has done a tremendous job of assembling great examples and deep explanation of what's going on with GitHooks. Um, but basically, you can put anything in a script. So here is an example script. So if you open up a GitHooks from a new GitHooks folder from a newly initiated um, project, you're going to find some samples in there. So there's apply patch message sample, pre-commit sample. This is what pre-commit sample actually looks like. If you erase the dot sample, then it will run. Then Git will pick it up when it goes to commit. It will run pre-commit. All right, now I'm going to go run this script. So this code is actually written by Linus, I believe, or someone early on in the project. And unless you are fairly gifted at scripting or know Git plumbing pretty good, maybe this doesn't make a lot of sense to you. However, you can make it do anything you want. Like I say, this is your script. So this is an actual script I run on commit message in my actual workflows. I like having dad jokes spit back out at me in the terminal. Maybe it's a little dumb, but shout out to Ed Thompson, who maintains NPM these days. He was the maintainer or the chief lead on GitHub Actions, and he also maintains a project called libgit2, which is how a lot of the world uses Git. But he also wrote this thing called I Can Has Dad Joke. I'm sorry, Git Dad is the project he wrote based on I Can Has Get Dad Joke. Basically, you curl I Can Has Dad Joke.com and it spits back a dad joke. Is it dumb? Yes. Does it make me laugh every single time? Well, about half the time that's true. Anyway, this is just an example. You can do anything you can script, you can absolutely make run. So, getting back to our problem at hand, how does GitHooks play into that? Well, let's think about the solution if we were to build a robot. We would tell it in a modified Gherkin language here. Before I commit, before the commit is actually finished, I want you to check my code, make sure I didn't hard code any secrets. And if I did, stop what I'm doing, throw me an error, and do not make the commit. Pretty straightforward. It actually is very straightforward. You can build this yourself. It doesn't take that much scripting know-how, but it does take a little bit of regular expression. So I'm using Git grep. Git grep is, well, a tool built into Git. It works just like regular grep, except instead of the scope being all the files it can see, and then you have to specifically tell it which files. Git grep will just look at the indexed files, all the files that Git already has access to. So it narrows that scope and makes it a little bit easier to search just your repo. So regular expression, I'm looking for anything that looks like a password. Maybe it looks like that, or maybe it's a key that's all capital letters and numbers, and it's 20 characters long. That's what regular expression means there. And just spit me out an error if I try to commit something that looks like this. And since password was the first thing it saw like, all right, I see they're great. no hard code password. That's what we told it to sell me. Yep. And it worked as expected. Truth is, you can build anything to do something like this, or you can build anything to look for any kind of pattern you want. But then the ultimate problem with that becomes um, you got to maintain it. Like you built a solution, great. One of my favorite quotes in the Drupal world ever was a guy named Jim Birch. He wrote a module for the Drupal community, and he said, "The best news is there's 100,000 people using it. The bad news is I'm supporting 100,000 people using it, and none of them are paying me." Um, you don't get unless that's specifically your job to go out and build security tools and infrastructure. uh, Maybe you don't want to get involved in this directly. You also got to go sell it to your team. You also got to get buy-in that this is okay to run. You're gonna have to get this vetted, keep track of what's going on. Oh, what about allowing code or allowing example passwords? Like this is an example password. No one's ever going to use that as an actual password, so it should be okay to leave that in there. Um, it goes on and on. There's just a lot to think about. Well, good news, GitHooks to the rescue. Our open source to the rescue using GitHooks. AWS Labs, they have a pretty big stake in the DevOps community. They're a pretty big player out there. They they built something called Git Secrets that specifically meant to help people not commit their passwords and API keys when using AWS. Basically, this isn't a full blown tech demo of it, but it allows you to install the tool on your machine. So you have a globally, it's there, Brew or PowerScript or PowerShell script or what have you. Then per repo, you declare that, hey, we're installing Git Secrets here. So it'll run on this repo. And then once Git Secrets is up and running, you tell it what to register. And we'll talk about that register here in a second. Um, then you can start going through and say, all right, we know this pattern for our company. This is how we use example passwords, or this is what our example API keys look like. You can start adding those in there as you see fit. Once it's installed, this will run every single time. Um, that's a great question, Sean. I see there, and I'll get to it in a bit. Um, so, what does it actually do? Well, what it's looking for are these things out of the box. This is what the AWS team said. Hey, this is what our keys look like, and these are the patterns that we want to disallow. So if someone said a key assignment equal or colon, um, but also let's start allowing this pattern. This is the de facto Amazon AWS example keys. These were copy pasted from their docs. Um, Also, AWS allows you to have a .aws folder, so that's where you keep. It's the equivalent of a secrets.json, but the AWS/credentials folder it should stay way out of your repo. You should put it somewhere like your home folder, where you're never going to commit your home folder, uh, and just keep all of that away from your code as much as you can. But it's looking, it will look in there and say, all right. I'll look through your credentials folder, and all right, if any of this is in your code, we will just stop you from doing this. What does this actually look like from a code perspective? Is this onerous? Is this a lot of code to manage? Nah, actually, it's not. Um, inside of every those three, um, inside of the three hooks I mentioned, commit message, pre-commit, and prepare commit message, it adds a single line. It says, "Hey, run Git secrets, run that particular flag, and then do it for the input, whatever your computer's looking at, whatever bash or zish is looking at." um, and then it adds into your git config. So again, if you haven't looked in your git folder, look in there. There's a config file that overrides your global. So you have your global git config that announces who you are. But if you are working as multiple personalities or multiple personas, it's pretty easy to go into individual folders and make a config file for that folder. So in that file, for that repo, it adds all of these patterns. And it's already written the regular expression for you. In my experience, the hardest thing in the world is regular expression. It just is. The fact that this team already did it is pretty awesome. So, what does this actually look like when you run this? Here's an example. Was working on. I did this in a README, and I did this with totally fake keys. So nobody worry. I'm not exposing any secret here that shouldn't be exposed. These are made up based on the example repos or example code they have. But anyway, I tried to commit it, and here's what it spit out. Now you notice it actually detected two different things on two different lines, and then gave me a bunch of mitigations. Again, something I wouldn't have thought to build in if I was building this by hand. The fact that I'm going to help myself later with any of this code is cool, but it's not top of mind. So I'm very glad that open source has given this to me. And to your point, Sean, well, that's all well and good for AWS users, but what about me? I use something else. Uh, the last place I gave this talk actually was at Azure Spring Clean, which happened a few weeks ago, which is an event all about cleaning up your repos and cleaning up your DevOps practices. Well, once again, open source to the rescue. Because AWS open source their code, everyone could go in and see exactly how it works. Fun fact, go back a few slides. This code here is modified from what I found digging through the AWS repo. Uh, it's how I learned a little bit more about how regular expression worked and a little bit more about how get grep worked, and I learned a little bit more about how all of this works together because I could dig through the code because that is the power of open source. I'm a big believer in open source for the code and closed config. So uh, I think we should all benefit from that. Anyhow, for Google Cloud product, there are a lot of variations. There's a lot of forks. These are both forks of the AWS Get Secrets repo. Um, but these are just the first two I found that I said, all right, these look pretty good when I looked at the code, looked at the issue queues and whatnot. Um, I'm not going to try to pronounce these, but you can see them on the screen. If anyone else tries to pronounce them out loud, feel free. Um, but they both add the add AWS or add GCP. This one adds the register GCP, which goes through and adds the same set of patterns. Go explore them on your own to see exactly what they add and how they affect the code. But AWS actually built in the ad provider. You can go in and completely register this yourself. You can also add anything you want. You can add global expressions, literals, allowed. You can modify this to your heart's content. And you already have access to this. So Get Secrets is open source. Go ahead and download it. But the underlying framework of how all of this works, you already have access to. It's already in your code. It's not something you need to go ask permission. Hey, can I use Git? In general, yes. If your company's not using Git, go ask that permission. Um, but it's something you already can access. It's something you can already get your hands on right now and start leveraging right now. And this is just the beginning of it. Um, this is one security pattern. I'm sure in a security conference like this, there's a lot of ideas brewing of like, well, could I also automate this? Could I also run this other tool? The short answer is yes. If you can imagine it, if you can physically type into a terminal to execute a thing, you can automate it. That's one of the beauties of open source and the awesome things about the command line is the command line is extremely scalable, extremely automatable, and it's only really limited by your imagination, time, and ability to research. The good news is that almost every problem out there has already been solved by someone else, and they probably released the source code already. Again, go open source. So I'm at the end of my talk. I am happy to answer more questions, but what I want to leave you with is don't hard code secrets. And I know I'm not going to stop anyone just by saying that because we all do this. We all check occasionally just to make sure that database credential is right. I know I have done that more times than I should. Um, but do not commit those secrets. If you do put them in your code, get them right back out. Don't get distracted. If you put them in, put some giant honking notes around them like, hey, remember to remove me. But also use automation to make sure that it's the big honking thing that yells at you, hey, you tried to commit something you shouldn't have. Go ahead and stop it already. And make your workflows your own. Whether it be a dumb example like throwing a dad joke in with I can ask dad joke through get dad, or doing a full blown security suite test every single time you try to commit code, it's up to you. You do what makes works best for you. So I'm Dwayne. I work for a company called GetKraken. You can email me directly at dwayne.mcdaniel@getkraken.com. And always feel free to hit me up on Twitter. I will answer questions about improv, knitting, crochet, uh, Chicago in general, but also tech and Git and many, many other things. So thank you very much again, besides Tampa, for letting me be here. And I did reserve about 10 minutes when I ran through this for a question and answer because they said I had 45 minutes, but I'm a little bit ahead of schedule. So, um, does anybody have any questions out there? For those of you that came in late, because I saw the numbers went up. Um, yes, I can ask dad joke. I wanted to show this. Get dad. Oh, yes, get dad. Edward Thompson's Get Dad. I highly recommend everybody go install this. Um, basically, when you type Get Dad instead of Get Ad, and we again all do that, we all fat finger things sometimes. Um, it will just spit back a dad joke. But if you look in the core, again, reason I love open source, this is the entire thing. This is the whole project. It's a script that just curls. I can ask dad joke. I've applied that to a number of other projects I have worked on. Actually, while I'm here, I'll go ahead and share these slides with you. Think do put those into the chat here. Those are my slides. All right. Anybody else have any questions? It's the other time since I'm here. AWS secrets. Go to Google to ask for something on GitHub. Oh, yeah, okay. Got questions coming in. What's the most common non-obvious secret you see committed? Passwords for what we think of as non-vital systems, I believe is what that report said. Uh, so if we go back to my intro here, yeah, Git Guardian's State of Secret Sprawl 2021. So they did the research in 2020 and then released it in 2021. But this is the report. You can see here yourself that literally outlines this entire problem set. I had nothing to do with this. This is just research I am leveraging out there. Um, but yeah, passwords are very easily uh, put in for just checking to see make something works, and then forgotten about. Oh, example, something that's not a password or a key. Um, that's a good question. Most of my research has always been around those major pieces. I'm sure if we go through back to this report, there are would be some things that are not obvious. If anybody else has some ideas out there, um, feel free to pop in. Okay, Sean's asking, what about writing your code to use AWS Password Manager as your key vault to have your code check out your keys? Have you seen people use this as a mitigation? Absolutely. That is the perfect solution. When I was talking in Azure AWS our Azure Spring Clean, that came up. That specific thing came up, and Key Vault for Azure is a beautiful system, and there are all sorts of secret managers you should be using, and then just referencing. So we're calling. So for those of you who might not be familiar, um, secret manager like Key Vault let you store your secrets and then manage those secrets. You can leave, group them together, give access and permissions to your teams, and then call them programmatically. So instead of calling hard coding your password, you're hard coding a call to your secrets management. At a certain level, though, you're just abstracting the problem out one abstraction, because how do you manage the secrets and tokens and access for key management? Yes, it's a much more secure system. Yes, it's way harder to bust into. It's kind of like hosting a site on GitHub versus a shoebox in your closet. The shoebox in your closet just not going to have near the security of GitHub. And but GitHub's just a system with passwords. Like theoretically, if someone has the key, they can get in and mess with it. Um, so yes, in a perfect world, again, we would use key management. We'd call over the wire and purely encrypted, maybe tore it up, make sure that nothing's going to ever figure out where those keys are stored and whatnot. And they do help. I'm not saying they're bad ideas, but reality is people are still going to always hard code secrets occasionally just to check things, and they shouldn't, but they do. And so this team here, I don't think anyone at this conference, I really don't. Watching the other presentations and understanding like what this conference is about, I don't think anyone here is doing this. I don't think you're the problem. I think the problem lies in people not knowing, hey, maybe there are tools to help me with this. And that's part of my reason to be here is I want you to all help spread the word. If you know a developer, send them this repo and say, "Hey, did you know this exists? Did you know you should be managing your secrets a little bit better? Did you know robots can help you? Do you know you already have the tool that underlies how all of this works?" Send them my slides. Send them a recording of this talk. There's a page on GitKraken's website about this. Just look up Git Secrets, GitKraken, and you'll be able to get there. Um, but yeah, that's the whole goal here. Is I'm not preaching to you to like change your ways. I think this group is really embracing security overall. Um, but you know, people that aren't, go talk to those people and help them see the light. All right. Any other questions out there or anything else you want me to speak on? Not. We can go look at the code real quick. Um, where is yeah. So scans that it would have taken me a while to figure out how to write myself. Again, they're already written. Um, anyway, this isn't a talk to get in diving into code. Just wanted to show off the repo where I based all this off of. Because when I found this, I got really excited. It's like, wow, everybody should know about this thing out in the world. All right. Any other questions? I think David, then we can wrap this up. Give everybody a few extra minutes to relax, get your coffee, get your lunch, and get ready for those next sessions here at B-Sides Tampa.
Thank you. Thank you for your great presentation. I really appreciate it. And Git and GitHub and GitLab is always, very sensitive. And, the bad guys on the internet, they always looking for the secrets from the source code. And so in that way, they can, uh, break into the applications. I really appreciate your presentation. Now I will stop the recording and end this session. So thank you. Bye.